Yo, welcome to a thing. Now we've got an epic infinite loop, and now we don't. And the stream begins. So, what is happening? That is a good question. So, if you haven't seen episode 1 and 2, you probably should. If not, it's fine too. This is the link if you're interested to the playlist of all the episodes and stuff. Full link is here, but it's really long. Just use this one. It's jumpre-playlist 1. I hope that works. Players confuse me, but yeah. So I guess I should, in case people just want to watch straight from this one rather than going back, I'll give like a rough idea of what's going on. Basically, you can connect these up in different ways. You want to get this cheapest way, so here's 21, it's not the cheapest, here's 13, which could be the cheapest. I think it is because we use the correct algorithm. But basically, doing algorithms yourself is no fun. That's what computers are for. So the idea is we make computer do this algorithm. We've got 2 parts of the way there. There's 4 parts. We've got squaring 2, squaring 5. Oh no, I didn't get chat. No, I forgot to set up chat. Oh my goodness. Bruh, what a streamer. I got a device to do chat on. Bro, I might need to go back to setting up the stream. I forgot to get chat. I'm gonna do that. I need chat just in case I get viewers. I might not. Alright, one sec, I'll be back. Yeah, I just need to get Twitch chat. That is the wrong one. Wow. Epic fail time. Oh well, at least I had a playlist. And we made it. Was it worth doing? Well, I've got 2 viewers, so totally worth it. Like 8 minutes in, we haven't done anything. Let's go. Okay. So I did some of this, and then that happened. What is there to say? I've lost my complete train of thought. Oh, there's no chat rip. It was all a waste. Okay, so we got this process going. Let me get a color. Green. So it goes 1, 2. What happens after that? That will circle alpha. So then we'll do 3, and then 5. So those are the 4 steps. So far, our computer friend has done 2 of them. It's done 2 and 3. And so it can calculate out. No, this is not code that we want to run. Where is it? Code that we want to run. This is not how it's going. Oh boy. Why are there so many tabs? Oh my gosh, everything's a mess. That's what happens. It's only been 2 episodes in. Everything is just a disaster. No, wait, have I got microphone volume? Oh, I have, but it's so quiet. I'm so. Oh wow, what a streamer. Oh my days. How long have we been going? 8 minutes. Let's go. Alright. Okay, right, so back to figuring out what's happening. That's a big question. Big question needs big answer. Okay, yeah, this is our script. And so far it's done the first 2 steps. It should have got a total of 5 so far. So it can run. It can. Why is it printing out everything? Oh, because we told it to print out everything. That's 5. So it's done the first. What's happening? Yeah, first 2. 2 plus 3, 5. So the next one we want it to do is 3 here. Done 2 iterations, 2 then 3, that's 2 iterations, just 2 more to do because 2 more rows that we haven't cancelled yet. I think we've actually got all of the elements of this because that's what's being put out into the output here. So now we just need to sort through this and figure out what's going on. Before we do that, there's some serious organisation work that needs to be done on like a crazy scale. So, wow. Realizing you haven't set up the stream fully really isn't good. What is happening? Here it is. So the last episode I did like a to-do list of things to do. And I did this, which I said I would. This is just me keeping track of it more than anything, by the way. So before, we had 2 methods here. We had get column. No, we didn't. We had strip column and we had strip dictionary. I had the original code to show you, but I really can't be bothered to find it. But now it's all condensed into one method, which is, yeah, it's probably good. And the second thing, wait, I need to do like that. The second thing is look into fast documentation. I did it. You can like do like a little comment here. It might be like, well, why would you put a comment here? Because the code's right here. But if we're down here, we can't see the code, but now we can still print out that comment. So if we print, no, we can even be epic gamer than that. We can go straight to the console, print help. No, we don't even need to print. We can just go help. What was it called again? I have a list of the methods somewhere, but I don't know where. Sometimes. Oh, this is the old code. We don't need that anymore. Bye. Okay. That should make things a bit easier to see what's still not clear. This is probably, there it is, method names. So if we wanted to get documentation on get column, then we can do help get column, get the column being here, boop, and it will give us some information on it. So it tells us the parameters of column ID and the matrix we want to get the column of, and that tells us what it does. It turns a dictionary of the elements. Yes, and then it tells us what it returns as a variable name too. So that's good because it will help organize things. These are the 4 methods that exist. Thought that I would keep track of them here to make things easier. This here do not need anymore. So we can put that in our irrelevant tab, which is basically, I'm realizing now, is just the delete but not delete. So that can go in here. Boop. Hello? That didn't work. I thought I copied this. Oh wow. Ditch in there. Bada bing. Hey. Do, 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 do. Great. So that's also done. Oh, there's one fast documentation I didn't do. So we got documentation on that one as a comment. Oh, I wish the scroll wheel worked. Got one on this one. Got one on here. Didn't do one for this yet. I probably should. What does this method do? Should be able to tell you what this method does. What do we input? We input the possibilities of what it could be. Oh, finds the best value of the values inputted, then returns that value and the index associated. Let me copy paste this. There we go. So all we're saying is, go back to the image. Yeah. All we're saying is that it'll look at all the different possibilities. So here it has possibility of 5, 3, 11, and then it will get the best one, 3, and it will give the index associated, which here is C because it's on the C row. That's all it's saying here. Great, we got documentation and everything. We've also tied up the code a lot, so that's pretty pog. Oh yeah, this code. This code is really important, but not right now. What this is doing is it's letting us get a matrix. So here we set up an empty matrix. Now what we do is we put these values in here into the matrix accordingly using this script here. So we want to save this code, but we don't want it in the main document now. So created accordingly named get matrix elements file. Boop, it's going in there. That's good. Save that. And we can finally clear this mess. Oh, it feels amazing. So here we got our methods. 1, 2, 3, 4. They're going to be useful. And then here's our main script. So we assign a matrix. Right, and at the moment it's like a linear list, but as I was saying earlier, we can think about each part in terms of cancelling a row. So we go on this row. I've decided this row doesn't count. This one here. Here we need to scrap row A because that's just what the algorithm says. It's not really a part of the script. But then cancelling row B and then row Z is part of it. So these count as iterations. So we've got iteration 1, iteration 2. Then we're going to code in iteration 3 and iteration 4 today. So we can think about the section of the code in terms of which iteration it's on. So this is end of iteration 1 because we're disregarding a row, which is what? Or is it? Yeah, when we cross out a row, that's the end of the iteration. So this is the end of iteration 1 where we've selected 2. And where's the end of iteration 2? Third row discard. Yeah. Let's put a second comment. End of iteration 2, bracket third row disregarded, because that's the third row but second iteration. Seems good to me. And then what's happening here? Oh yeah, faulty code. So I wrote this code last time and I'm realizing now, on hindsight, this isn't a good way of doing it, so we're going to try and fix it today. So if we run this code, we get total because it's total, but you can see here we've got a collection of different things. So what we got here is we've got column A, column B, column Z, which is column A, column B, column Z, the 3 ones that are circled, but at the moment it indexes it by it. And that might seem fine, but the problem is a method we're going to be using. Oh, we can minimize this as well. Can we? Oh, I should read all the stuff that I've put here. Place call under first section with function call. I know what that means. Oh, no, I can't be bothered. Let's not do that. Make documentation stuff less messy. We fixed that because we used this to fix that. We looked into the triple comment thing. You know what I'm talking about. We just wrote some English literature to describe it. Wow. multidisciplinary. Just generally fix up the code, bro. The bro moment. Fix the top of the code, we did that. Okay, we're done with this then. We've done everything on the list. Well, except for this, but we're ignoring that because onwards and upwards. We can actually get this finished today. Well, we got the first part. The first part is doing it on this array. And then after that, we're going to generalize it for any array, is the idea. Unless I lose the will to continue with this project. This project seems pretty good. So, let's create I need to get my function list. It's not labeled. That is not good. We need to name this. Functions. No, just call it methods. Yeah. So these are all the methods that exist, and that's pretty useful. So the method we're going to be using to find out that the smallest number here is 3, we can just look and see 3. Computer can't. So we're going to use the choose best method. But the choose best method wants things inputted as, I'll give the format it wants it as. It wants it as like this. This is how it wants it. But clearly we don't give it in this method, in this format. I did it lowercase d. Boop. So that's the method. That's the format it wants it in. But currently we do it in this format, which is wrong because we're labeling them rather than just listing them off, which is what we want. So we can just put this code in the graveyard. Let's go to the graveyard. Boop. This is the graveyard now. There we go. Gone. Yeah, this is irrelevant. We're fixing it. Okay, so instead of having it like that, fixing the code. So here we got this, but we want this instead, so we'll just switch it. This is a dictionary. This has things labeled by letter. But we want an array, which is just listing them without naming them. So that would be like this instead, where you just have a list of stuff. So we've got an empty array, or list, whatever you want to call it. And we're saying for target ID and target IDs. All that's saying is for the circled things on the top thing. So we've got 3 circled things. So this currently has 3 objects in it, A, B, and Z. I'm going to say, what am I doing here? Oh boy. What do we want instead? Next column. Yeah. Next column possibilities is what that stands for. It's just equal to... Oh, I just realized something. Why have I not done this before? This is going to be Epic Gamer. Oh, are you ready for this? So here, before we were getting the column, and then the next line we were stripping the column, but we can totally just compound them into one what do you call it? One line, and that's going to be epic. Oh, yeah. Fourth thing, next column. Oh, instead of next, it should be current. I think that's slightly more clear. Current, because this is going to be iterate. Let me put that comment. Iterates 3 times. Fourth thing, column. Current column. Wow, that's a tongue twister. Current column possibilities. Why have I called it columns? That name's not very clear. Let's go possibilities 3. Why is it possibilities 3? Because we're on the 3rd iteration. We've done 1, 2 iterations. We're on the 3rd. Boop. This should fix everything, and it's going to be great. It's just going to be the best. Thing. What is a thing? A thing is just a thing. So it's either that's a thing, that's a thing. They're just. It'll work. Don't worry about it. And if we wanted to go really fancy, we could just shove that all on one line. Is that messy? I don't know. I like shoving things on one line. It feels cool, as you can see with this mess. No, but it's cool. It's just 2 lines into one. Nope. It's because the array that we're trying to print doesn't exist anymore. Swap it in with the one that does exist now. Hey, that is exactly what we wanted, as we can see over there. So what have we learnt now? Not learnt anything, we're just coding. Right, we got a list. Hey, we can do cool stuff now. We can copy paste code. Oh, this is what programming's all about. So we're saying our new small list and our new target ID. We're going to use our choose best method, our best friend. And this time it's possibilities free. We're going to shove in the big number constant because we can. It's just going to make sure that everything works nice and well. Now what? We can increment total by smallest. We can do target IDs. Append target ID. I'm actually going to print out target IDs here just to make sure everything's going well. Then put a new target ID in. Yeah. Seems fine to me. I know I'm doing something wrong. No, I'm not. It's all good. Is it? We've added the small. Oh, we haven't disregarded a row yet. That's not okay. Oh. Let's do it all on the same line. Because you kind of cross out and why have I got such an obsession with shoving everything on one line this episode? I really don't know. Maybe it's just because Python's cool, you can shove everything on one line, it's epic. You can probably do this in other languages. You can do this in C++, I know you can do this in C++, I need to calm down. Target ID. Oh, there's probably loads of languages you can just shove everything on one line. In fact, what languages can you not do that? Or maybe assembly, different sorts, you probably can't. Right. Yeah, we can test run with that. Yeah. Yep, as we expect, we've now got A, B, C, and C. No, why is it? Oh, yeah. Computer's better at reading than I am. Wow. I did not spot that. And this is why you make computers do algorithms. They're much better at it. And now we've got C circled. We've got all 4 in our array of target IDs. Very cool. And only one more iteration left. Let's go. Okay. We can copy this code. We should probably function this code. But right now I just want to finish. I just want to just keep going. Keep going till it's over. We can get rid of that line of code now. I can shove this on there. Oh, by the way, in this YouTube description, YouTube's removed arrows. I love arrows. You can't type them in descriptions, at least for the stream. I was so mad. So I had to type, instead of this, I was typing left arrow. Oh my gosh. YouTube, why? I want to be able to type arrows. Why can't I do that? Come on, YouTube. So yeah, you try it. If you try and stream and you try and put in your description an arrow, it just doesn't let you. End of iter. I'll type out iteration in full. I'll make it more clearly to iteration free. Great. What's happening? I have no idea. My brain's frazzled. Oh, we're nearly there. Oh my goodness. This is epic. Okay. We disregarded the row, didn't we? That's important. Possibilities for the final iteration. We're nearly there. Target ID in target IDs. Current column Ps. What's that? Current column possibilities. Okay, current column. We're going to get a column, which is at the target ID of the iteration. It's going to iterate 4 times. Fourth thing in current columns possibilities to append. Okay, we just need to append it to the 4th one now. Okay. We can just copy code. Probably, can we copy all this code? Oh my gosh. Maybe. Copy code. I mean, this is very repetitive. We should have done it inside a loop. That's what's going to be the next step. It's just I wanted to sequence it out for now, just so I can have a rough plan of how the final algorithm's going to look. And it's going to make me feel really silly because the final algorithm is going to be so compact. I'm going to be like, why didn't I just code that the first time? The thing is, at the bottom of the mountain, you can't see the way up. Add total. We append the tire ID. We don't need to do that anymore. We don't need to do any of this because we're done. That's it. Guys, we did it. That should print out our total just because I want to see that it's working. That should print out the smallest one here, which is 5. That should print out a total of 5 plus 3 plus 3 plus 2. 5 plus 3, 5 plus 3 and 2. That makes 10. Something's gone wrong. That's not the correct answer though. Here it is, I can't count. 7 plus 6. Why couldn't I count? Oh, because it's 5, not... Let me just ask Python. Python can do this for me. Computers are amazing. Why does I not use the computer? 13. Okay. So it should print out 13. It's not going to disregard the row. It doesn't need to. It's finished. It's done here. Although we could disregard the row anyway. Let's disregard it anyway just because we want to. Just because the disregard row method is amazing. When I coded, I was like, oh yeah, why would I bother coding this? But I've used it so many times it was worth it. D. Why is it saying D? It's chosen D. Yeah. Oh, because here, D. Fair enough, computer, fair enough. Okay. It did it, yay. I can't believe I'm at the end. No, wrong thing. So this should... Yo, this is crazy. I can't believe I actually made it. That's a lot of work, but we got there. This should, in theory, work for any given matrix. Oh my goodness. Let's do it. I just want to copy paste the code because I don't want to lose anything. So where we got matrix here, we could put any matrix in. Whoa. I have to try that. And then eventually we're going to need to post out the route it took to. Oh, that might actually be a pain. It might be okay. We'll see. What am I doing? Oh, I'm making a network. I can do whatever I want. Only it has to have how many nodes? Because of the way we've coded it, it has to have 5 nodes. Boop, boop, boop. This episode's way more exciting than last episode. Oh, and there's no one here. Sad times. I had loads of people last time. Oh well. It is what it is. You win some, you lose some. And what's cool with YouTube is you'll stream it and get like either some viewers or no viewers, but then after it's uploaded it will get more viewers, which is so much better than Twitch. Like Twitch, once you finish streaming, it seems to just die to the internet. I don't like that so much. At least with YouTube you can get a second audience from after it's uploaded, which is very nice. I like it. I don't know how many, I can have as many arcs as I want. Bro, the world's mine to conquer. This is epic. I don't want to do all the arcs because then it'll be a complete one and then it won't show as much computer talent as if we don't make it complete. Okay, we can choose some numbers. And so it's going to tell us the cheapest way to connect all of them, which is like, what? Is this real life? But yeah, we live in a modern age. Computer technology. For this one it's slower because obviously we've got to type it all out, but for bigger ones where you just like where you have a lot more, then that's when using a computer would be like. But even this is like, if I was to do this out manually it'd take a bit of time, but with this it'll take less time once I've set it up and it will guarantee the right answer. Very cool. Problem is, this actually takes a long time. So I guess I'll only do one example. I was about to be like hyped and do loads of examples, but I don't even know why I'm doing an example. It's probably not worth it, but yeah, we're doing it now. A to B, none. Oh, the cyclic nature of it. We did this earlier in like an earlier episode. Wow. No connection. B to B, nothing. B to C, 11. B to D, 4. B to Z, 6. So distracted. 7. Say Mario Kart DS, my brain is like, Mario Kart DS? Can I play that? Yes, but you're coding because it's more meaningful. I don't know. So that should be the thing. I'm just realizing it's not going to test the root, so it's just going to give us a number at the end. Which is kind of sad, but yeah. So you know that code I said, oh, it's important, but not in the main script? That's what we're going to be using now. The one which is going to get the matrix elements for us. It's going to be super useful. Hello? Oh, it's right there. Something's lagging. So now we need to copy out this into this. Does this just run? If we print out that, comment out that, then here we'll set up a matrix. This is all empty, I assume. And then I assume this is the code for setting up. It should work. Let's just type in the elements. E 3 5E empty 11 4 6. Bother, they don't line up. That's going to be annoying later on. 7 11 empty 3 empty. And now we just need to reflect it, which might be easier in the terminal, which is why I didn't reflect it over there. Definitely seems to be that way. Oh, reflecting is weird. It's not reflection as you expect, it's like a diagonal reflection, so it ends up being super weird. I think I'm doing alright. Is that nearly done or is it not nearly done? It doesn't look symmetrical, but then I guess it is. Oh, we can do that too, to get them spacing out. Now they're online, but this is also taking a while, and definitely my viewers are going to be gone. Okay, is that a thing? It's hard to see if it's symmetrical because it doesn't look symmetrical, but then it's just the numbers. It's going to be so good once we have a script that will do this all for us, which is eventually the end goal. I think we're done. I never printed it out. That's going to do absolutely nothing. But okay, and there is our matrix. It looks like a mess because it always does. Wow. There we go. Is that going to work? It's going to give us a number, for sure. And then we'll have to find... No, it's not going to give us a number. Why is it not giving us a number? We never told it this is a matrix. Lol. Okay. Now it knows matrix is that. 15. Was it correct? I have no idea. Let's perform Prim's algorithm to find out if the computer got it right. Probably did, hopefully. Actually, we're going to use cross scales. I haven't spoken about cross scales, but the way it works, you just keep choosing the lowest without causing a cycle. Cycle is where it all links back to itself. That would be a cycle because it all connects, and it's not okay. So if we do a cycle, we'll be able to go on a continual loop. That's not okay. So no cycles, we keep choosing the lowest. Choose that lowest, choose that lowest. What's the next lowest? 4. Next lowest 5. Can't you choose 6 or make a cycle? Is everything connected? It is. Okay, 3 plus 5 plus, let's put it in Python. 3 plus 3 plus 4 plus 5. 15. And that's the answer we got. It did it. Whoa. Epic. And we have a working script for 5-node matrices. Now let's optimize the heck out of it. Alright, version 4. Version 3 was just testing it. In case you care about those things. I know I certainly do. The biggest problem is going to be that we used arbitrary names here. Can't be arbitrary if we want to generalize the code, which is our end goal. And that is a big problem. What's the camera setup like? Oh, the camera setup's pretty good actually. First thing I want to do is I had this idea recently. I noticed that I remembered in C++ you have like a main function, and all your main code goes in main. Here we've just called it main, like self-called main, but then it's not inside something. I found it's quite nice to have it inside something, so I thought it'd be good to just put this all inside something. Might make it neater, it might just do nothing at all. I did nothing at all. I'm just going to put it back to how it was. And by it did nothing at all meant I couldn't see a difference. I was hoping it would look a lot better, it didn't. So here we disregard the 8th row, but then A is completely arbitrary. We just chose the letter A. What's the best way to approach this? Might be best to turn it into iteration first, and then worry about everything else later. I think that's what I'm going to do. The arbitrary names is a problem, but the fact that we sequence out every single iteration rather than doing it in a loop that does it for, like, I'll explain. We don't need this anymore. We kind of do. I need everything. And that is why I struggle to find things later. Okay. So at the moment, these are our 4 sections of code to complete the algorithm. But we've written out the code for each section. What would be nice to do is put it inside a loop. So we might have at the top say repeat for. Wow, it takes a long time to write out repeat. Oh my goodness. And then like if it was scratch blocks, going back to scratch. Then we don't have to write the code once. And these two would be the exact same. Only here, one of these sections is now here, and it repeats it 4 times. And it changes only the tiny things we have to each time. Because it's crazy with these, like each part is very similar, so we can generalize it into one thing, repeat it 4 times in each time, change very tiny things to make it all work. So, how does that look in practice? Good question. That is the question. How will this look? What I'm thinking is, we'll take the latest iteration, so end of iteration 4. We never wrote end of iteration 4. Where does it end? Here. As you can see, here's the end of the second iteration. Here's the code for iteration number 3. Here's the code for iteration 4. Or did we skip things the 4th time? I don't think we did. We could have, but we didn't. So you see the code's gotten smaller, but it does the same thing. That's what tends to happen when you do things a lot of times. You get better and better at it. So we might as well take the code from the 4th one and try and generalize it for all of them. Take the best one, figure out how to make it loop. This is the goal. So here we're saying possibilities 4. But we might as well just say possibilities if we're generalizing. and get rid of that because we don't know how many times it's going to iterate, because again, generalization. Target ID in target IDs. Okay. Current column possibilities, get the right column, fourth thing in current. Also, because we've got way less code now, we don't have to condense, so we can space things out a bit more. Because we're dealing with way less code now than we were over there. Kowalski analysis is what this is. And get rid of that. For thing, we should probably name thing better if this is going to be our only code. What is thing? I said this earlier. Oh, it's one of those elements. Oh, we could call it possibility. Because we've got our possibilities. We're keeping track of all the possibilities there are. So we're saying for a possibility in our current one in a loop of target ID is kind of a gross name. That is what it is. Yeah. Pete's waits through target columns. Current through. No, we don't need to name this. We don't need to name the code. The code names itself right here. It's fine. And that's good because it says possibilities to append possibility. That's really clear, which is good. Saying smallest target ID. Saying a double variable declaration is equal to this function, which does good things. It's now called possibilities. Again, we've got more space, so we can do that. Total plus equals smallest. Could even do this if we really want. I don't really want. I want to condense it. We're adding smallest to total. Disregarding the row. What am I disregarding the row of? Disregarding the row according to that. And the final step, we did miss a step here. Where do we want to add the target ID to target IDs? Before we disregard the row, because that's when I do it as a person. I'll explain. So what I'm saying here is, it's actually cool how you can see the different parts of the code in terms of what you do as a human. This is why I chose to do it in Python. It's great. Python's amazing. So what we're doing here is this is the human equivalent of going, looking at these numbers, what's the lowest number? And then it will find out here on this line of code as the moment goes, oh, 3 is the smallest. Oh, I need a better color than black, red. They go, oh, 3 is the smallest. And 3 becomes the value in smallest. We add it to our total. So here we do 2 plus 3, that's 5 plus 3. So we say, oh, 8's our total now. Wait, hold on, I should make this more clear. So it's 5 before 2 plus 3, but then we're like adding 3. 8. That's what's happening here. We're saying, oh, we're adding 3 to 5 to make 8. And then what's the next step? The next step would be disregarding, actually. Or the question is, do I disregard, then highlight? That's the question I was asking myself just a second ago. Or do I highlight and then disregard? To be honest, I tend to do this, but which is more clear on the computer? Probably that as well. Yeah, okay, I'm overthinking this. Target IDs. Append. I think we've just, what do you call it? Revolutionized my code. I think that's it. That might be it. Bro, why didn't I think of this ages ago? I guess I was too worried about commentating, explaining what I was doing. And I wanted to make it flow rather than using my head to think what's actually happening. But that's fine. I'm happy to go slower and make it make more sense. Where's my diagram? Oh, too many tabs. Tab nightmare. Here it is. So you know the code I was saying we should put here? I think I've done it. This is the code. It's barely that long. Oh my goodness. Let's go. Oh, that's what you call PogChamp. What's this? Is version 4. I'm going to name it what I can. Prim's version 4. Epic. Right, so we need to get out, we need to extract from here the things we need. We can ditch everything else. So we need our function declarations. Be nice if I could put these. I can. Oh. How spicy do I want to go? I want to go super spicy. Oh, are you ready for this, guys? This is going to be amazing. This is going to be everything that I could have ever hoped for in a program. I'm getting way too excited about this. This is going to be epic, though. Watch this. Software engineer gets to use one of the techniques he has, or always gets excited about it. I'm going to explain this in a second. Boop. That's it. Alright, what we're doing is we're saying from this file, import these methods. So the methods can be over here, we can import them over here. So we only need 4 lines of code to do all of this code because we import the code. Let's go. Now this is PogChamp. We need these constants. Great, now we should probably declare all the constants we need before we start our iteration. So total equals 0, that's an important constant. What other constants are we using? Out of here. We need this because this is our main code. We're untitled. That's good. That's what we want. Oh, that list. How long is it? Oh my goodness, this is a tiny code project. How? This is what happens when you don't use a code editor, you use IDLE. I should be using PyCharm, but I just can't be bothered. What else? Total target IDs. Right, I do remember there was an arbitrary bit we did at the beginning that we need to do here. So let me add to my model. You probably already know what I'm saying here, but I'll just say anyway. What I'm saying is there's a bit of extra code here that doesn't fit into our iteration thing, so we're going to have to append it on top. That often happens with iteration. You'll either have something at the end or the bottom that doesn't fit in the iteration, so you have to do it at the start or the end instead. That's what we're doing here. That's what we're doing here. And that code is disregarding row A. And this is already, that's it. Let's go. Oh, we also need to put A in our target IDs, I'll show you. Boop. I want to put it on one line because we can. Target IDs dot append A, that's it. Now I can go straight into the iteration. What this is saying is it's saying repeat 4 times. That's just code for repeat 4 times. What it's saying literally is it's going to be I0, I1, I2, I3, because this is technically this. So it's saying 4 element I in this, so 0, then 1, then 2, then 3, repeat the code. But you can shorten that down to just boop. And you can use any letter here, but I is a cool letter. Okay. Where's my hammer time code? It's right there. Oh yeah. Why did it mess up the indenting? You had one job, Python. It's okay. We're going to outsmart Python. There we go. Cool. Actually, this isn't even Python. It's just IDLE being IDLE. Possibilities in there. Target ID and target IDs. Do we add a target ID? We do. We add a target ID. We disregard the row. We add to total, which is defined here. I think that should work. It doesn't feel like it should. Oh my goodness. To put this in context, I'll put this in context in a second. This is ridiculous. This is why I like coding. Because moments like these, we're like, oh no. It was too good to be true. Ah. Now that is a problem I'd never thought of. I was too fast. Too fast, no brain. Need to be fast and use brain. I didn't use brain. Brain turned off. Okay, I'll explain what just happened. What happened was, is we've got some constants here. These functions were imported, but these functions never knew about these constants, and we need these constants in these functions. So, obviously the big question is, then how do we fix it? The answer is, you can fix it later, but for now, I'm just going to do the obvious thing of deleting that. There's a way you can do it, but I just can't be bothered right now. That's cool. Yeah, we can do that at the end if I want to, but for now it's like whatever, bro. All right, now it should work. Nope. What's the problem? This it worked. Yes. Is that the answer? Is it? Oh no, but it's 13 rather than 15. Did we put the wrong matrix in? Which matrix did we put in? These are all good questions. That is not the code I was looking for. Version 3. I reckon it's already on screen. It is already on screen. Yes, this is a different matrix. Let's put the matrix in. We're expecting 15. This is our latest edition of matrixness. If we got 15, it means we condense like 100 lines of code into like 10. 15, that is our answer. Is it? Where's me checking it with paper? Only it's not paper because I'm on a computer. That's me talking, but realizing I can't talk without drawing. What's this? That's me counting up. 5 plus 3 plus 3. Oh, and I used Python before. I'm going to use my head now. Can I use my head? If I got enough willpower to do mental arithmetic, that's 15. That is the answer, isn't it? Oh, yeah, it is. Where though? We can close that. I'm always scared when closing stuff, but I really don't think we need it. Watch me have to reopen that file. 15! It did it. Alright, context time. What did we just do? Why am I so hyped about it? And why is nothing making sense anymore? All will become clear. Okay, so here we have, how many lines of code is this? We have 137 lines of code. I'm looking at this number here, it's probably too small to see on playback because I'm streaming at like 480p. 137 lines of code. Here we have 74 lines of code. Doesn't sound like less code, but like you can see it's less code. I guess because I'm not comparing main length. Let's do that instead. But will it tell me how many lines have I highlighted? Is that how many lines are highlighted? It's not. Oh, Python, why have you got to be like this? I've actually got to do math here. Okay, fine. 74 minus 48. It's 26 lines of code. Here we got 137 minus, this is important, okay, minus 48 as well. 89. So it's like 75% less code, which makes sense considering that we did turn 4 pieces into 1 piece. That suggests shrinking by 4 times, and we kind of shrunk by 4 times. So that's what we'd expect really, but it's cool because here it just feels like a lot, even if it is only like, okay, 4 times is quite a lot. Oh, the code's so nice. Look at it. And what's cool about this code is we're a lot closer to making it not arbitrary. Like shockingly close, actually. Because we use these arbitrary labels, but it doesn't matter because the code just looks past that and it works. Oh my goodness. This is so close to being like finished. Because all we need to do is shrink this from, if we just change this to 5, put a 5th symbol in, it will just figure it out. Oh wow. Where do I take this next? There's a lot of places I could take this. There's a lot of things I can do. There's no chat. Sad times. Should put some music on to make it less sad. But I can't code with music. It's not possible. The two things don't work together. You're either listening to music or you're coding. You can't really do both. Well, actually, you probably can. You just can't make a YouTube video and listen to music at the same time. It doesn't work. Big think time. Yeah, the biggest problem right now, like I can't believe that's literally the script. That's it, bro. I wish I had have just thought about it sooner and just not typed as much code as I did. But it's okay. It was cool seeing the process of turning it into that thing. Whereas the focus is going to now shift from this. We know what's going on here. We know that this is a way better way of doing it. Move it out of existence. This is the new focus, except it's not because it's so finished. We're going to shift our attention to. That's important, but not that important. Not as important now that we've implemented it into a function, not a function, a script that works. Where is it? Here it is. This is our new topic of focus. Focus. This is where it's at. So currently we can input elements through this interface, and that's pretty good, but it's not perfect. And there's a way we need to fix it somehow. Now we're wanting to fix it. Because already it's pretty automatic, because we could put in stuff pretty quickly. So for example, let's say I'm opening a new paintbrush. Hopefully my computer doesn't crash. How many tabs of paintbrush have I got open now? So let's say we wanted the matrix. Oh, hello. That's not going to have a number there. I'm just choosing values out of my head. So ideally, we want to be able to go, okay, Python, our elements are, let's have, we want a new flag called auto. I'll explain that in a second. So we go E1, 2, 1, E, auto. So auto is going to the things that don't exist yet, because these ones are just going to be this. So there's no new information to input. It just needs to be formatted so that these things here are filled in. Empty, 3, 2, empty, auto, auto, empty, 1, 5, auto, 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 empty, empty, A, E. And then, ideally, we'd want it to be able to figure out what these elements are. But how difficult is that? It's quite difficult, isn't it? And that's ultimately the goal of the next section. The goal is we make a function we can pass this to. It can turn from this format into this format where they're all filled in. I mean, technically we finished our start goal, which is to make Pascal's algorithm. Not Pascal. Pascal's cool, but he's not involved here. We want to be able to create we've created the script that does Prim's algorithm, this is it. But the problem is we have to construct this matrix ourselves, and ideally, oh, there's something else we haven't thought about yet. Oh no. How hard can that be to implement? Famous last words. Wait, I'll tell you what I'm thinking. That's probably more important, maybe. Debatable, but when we do AB, that represents the connection A to B. And so if we wanted to fully do the algorithm, we need to do AB, find out it's 2, but we also need to write down AB. And then after doing AB, where do we go next? We go BZ. And after that, we do, what do we do next? Oh, go ZC. And then we go BD. So ideally these 4 combinations of 2 letters, we all need to be outputted to the console. Currently it's just a number, which is cool, but it's not the whole of the algorithm really. But I don't think it'd be too hard to just implement. I think just YOLO it. I could save a copy first too, so it's not exactly dangerous. So we can have a previous node variable, start with A, as per usual, because A is our arbitrary starting point. We have to start somewhere from A. And then we got target ID. What point would I write out that? I'd write it before I add the smallest to the total. I would go let's do a solution. This is over-engineering at this point. No, it's not. It's fine. Solution.append previous node. Oh, previous node doesn't quite work either. Ooh. Target ID tells us which row, but it doesn't tell us which. Oh no, that's going to be way harder to implement than I realized. We don't know what node we connect from. So for example here we went ZC, but then, so what I'm thinking is that my algorithm is just going to say, oh, it's got B, so the next one will be B. That works for this one. This one works, the previous one was Z, the next one's Z. But here, the previous one's C, but oh no, now it's B. It's different. How do we find that it's BD rather than just CD, which is wrong? Answer: intense programming pain. There are different ways we could take this. Okay, let me script this out, not script. Yeah, kind of script, whatever. Yeah, another tab. So we could do, we call this solution finding, but then it takes forever to write stuff, so I'm just going to do solution finding being we figure out the path, which seems kind of important, but it's kind of like annoying to try and figure out how I can implement that, but I should probably think about it. Is this thing. I can even copy and paste that, which I will do. What just happened? I did something. Okay, that's that. It's one way we could do it. We could do matrix setup script. Why is writing so slow? What is a matrix setup script? It is this guy. I can't copy paste that. I can copy paste that. Let's go. It's tiny, whatever. Which is where we have our A's, and then we fill in the A's using the rest of it. That would be quite nice. It's quite important, really. Or, as an alternative to that, how can I show alternative? Connect them. I'll show it. We can have a user interface set up. So how would that look? I want to think about that now. That would be really fast, wouldn't it? Or would it? Yeah, it would. Wow, that'd be really fast. Oh, let's do that. Gosh, it's so late. Late night coding being really late. How long have I been going? Oh my goodness, an hour. Feels like I've done nothing, but I haven't done nothing. We did the final two, and then we condensed it. And then we've looked at the future. This is big future. That code we used before we can reuse here. Symbols equals that. This works, it's going to be POG. It's an input. Oh. No. I'll explain why I'm not doing what I'm doing in a second. 2. It's an input. Is that fast? That will look fast, hopefully. What we're doing here is we don't know if the user's inputted a number, because it could be a number or it could be a letter. What we're doing is we're trying to think of a different system. I can't explain it because I'm trying to see if it works. If it works, then I'll try and explain what I've done. But right now it's in like experimental stage. Oh, user in dot is digit. I'm hoping that's the way to do it. I haven't used it in a while. I should probably use a try except, but I kind of hate try except if I can avoid it, so I'm going to try and avoid it. I'm also not a fan about else, but else is actually really good here, so I'm going to use it. I don't care. Okay. So the goal here is we're saying if it's a digit, as in if they typed in an integer, we're going to make it an integer. If not, we're going to add it as it is. Now to find out if everything went to plan or not. Oh, I haven't saved it yet. Oh no. Experiment 1. What will happen? Oh wow, this feels amazing. This might be really fast and amazing. We might have yeeted a really hard problem. If we did that, I'm going to be so happy. Then none of them are named. Where's my made up network? Did I close it? I did, didn't I? I knew I was going to have to open something, even after having all these tabs open. What a pleb. No, those are thumbnails. Is it this one? Oh, yeah, it is. Where is it? Oh, no. Irrelevant 1. Did I ever save it? Oh, no, I might not have saved it. Oh, I'm so mad. It's not saved, is it? Oh, my days. No. Okay, I know what we can do. We can input this one. It's annoying because I've written all over it, it's fine. I'll figure it out. Where's the Python shell? It's claiming it's on screen. It's definitely not. A to B, 2. A to C, empty. A to D. It's cool because it automates stuff but doesn't at the same time. It's such a cheap way, but also pretty cool. It's also going to repeat questions. Not making it repeat questions is difficult, I think, so it's kind of okay as a solution. I think what I should look at first is how many connections it makes. C makes 2 connections to Z and D. So if it's not Z or D, we just skip. That's C, which is D, which is 7, and Z is 3. That made it quicker. Actually, significantly quicker. How many connections it makes? It makes 3. B, C, Z. B, C, not Z, Z. Z to A, 5. Z to B, 3. Z to C, also 3. 11. Does it connect to itself? Oh my goodness. Is that a success or is that not a success? I can't tell. Yeah, and we can make it even better by testing if it's E. I mean, it worked perfectly except that it's E rather than empty. The text editor let me just replace it? If so, that'll be nice. Place E with caps empty. Oh, winning. Yeah, that was quite fast too. Felt awful though, because I had to repeat questions. But then again, inputting elements to a matrix is never going to be good, is it? How can you do it well? Which method would be better? Would the auto method really be better? That method was quite nice. It'd be nice if it didn't repeat questions, but I don't think that's a possibility. Oh, unless we have it keep looking up a database to see if it's asked that question before. But then I also have to worry about it figuring out if it's either way around, it's the same question. Yeah, no, I think I like it like that. And it's super easy too, which means we can work on actual problems rather than just interface design. Yeah, that's good. What did we just do? We figured out that's stupid and we can ignore it by using that new method. Without this, good. Yes. Solution finding. Is that our next? Is that really all there is left to do? I guess it is. Gosh, isn't as hard as I thought. We've pretty much done it. Oh no. How hard would it be to solution find? It's the big question. The big question left to answer. Where is that data hidden that we'd need? Oh, I just had a thought. Oh my goodness, this might not even be that bad. Possibility. Pretty certain it's just a tuple of 2 elements. I set this tuple up, I think. Where's the possibilities coming from? It's coming from my strip column method. I'm pretty certain it's just a tuple. I can check really quick here just by printing out. Oh, it's possibilities. The heck? I don't know what that's doing. Yeah, they're all tuples. Do you know what that means? It means data manipulation time. That's what it means. That's what it means. It means instead of appending a possibility, append a new 3-item tuple. Tuple 1, tuple 2, And we can put whatever the heck we want on the end. What do we want to put on the end? We want to put target ID. Okay. Explain what this does. Let's print out. I'll just hard code the data into our print statement because I can. Oh, I haven't named it. Prim b5-experiment. If this works, I'm going to be, oh my goodness. You see what's happening here? Now what we're doing is we're saying, oh my goodness, that's basically it. That's unbelievably, oh, we're so close. I think next episode I can finish this. It's so close to being demolished. We're so close to demolishing this program project. 3 or 4 episodes, let's go. Yeah, let me explain this. Let me explain this. So what we're doing here is before we were just looking at what it is so we could figure out how to circle the next thing. Now we're saying where did it come from? So not only are we crossing out C, but it came from Z. So here it's saying if you went 3, that would be you need to cross out C and you need to keep a record of A. Why do we need to keep a record of A? Because this one might not necessarily be equal to this one, but if C isn't B, then we'll have B stored here instead. So it will get the B from looking at the third element of the tuple. So we've expanded our tuple from 2 to 3 to include more information so we can solve this weird problem here by storing more information so we can see the bigger picture of what's going on so we can solve it. Yeah, data manipulation in Python is where it's at. Like, you can't do this stuff in other languages because they won't let you put integers and strings together, but in Python you can. No questions asked. Okay, I think we're done. We're done here. Is everything done here? For today everything's done. What do I need to remember for next time? I should put that so I remember. On our version 4, no. Our version 5 script's already better because it does something that our old one couldn't figure out. But now it all works. Got experiment, we can change it from experiment later, but I'll just remember version 5 is the latest. What do we need to do? Use tuple, use new 3-dimension tuple to do what? Find the paths used to construct the solution array. Yeah. So next time we'll finish it. We'll be able to get our final number. It's not 8 here, it's 13, but it can do it for any. We'll be able to incorporate the 2 script ideas together. So we'll have the script of getting input and the script of processing our data together. And we'll have this thing implemented too using our new 3-dimensional tuple that stores the data we need. Stores that third item we need here, which is different to this item, which is different to the previous item. I should probably explain what I mean by that. Explain yourself. So here, for example, C and B are clearly not the same character. Sometimes the previous character is not the new character. So this character sometimes, like in this case, the previous character is the same. So for in this case, it could be A, and the previous one was also A. But sometimes it'll be different. But this one is stored as its own individual thing, which will allow this stuff to happen. So it will all work together and work. It's gonna work. It's gonna be great. That is the end of this stream. Thank you for watching. I hope things made sense. If not, leave a comment or something. I don't know. But I think episode 4 should be the end. I think I should be able to tie everything together and finish this series on Prim's algorithm in Python 3. So thank you for watching.